All right, welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 13, part 3 of our broadcast and recording together. And in the last part, what we did was we went through quite a bit of detail about what classes were. We talked about classes. And now what we want to do is actually create a class. Let's create the character class for your in-class exercise. So the first thing I want you to do is we're going to go back to our Visual Studio project, right? And what I want to do is I want to make a brand new item. So again, I right click here in the Solution Explorer and I go add new item. Okay, this is what I want to do. So let's start with that. Add new item. Right click, add new item. When I do that, you're going to see this new item dialog box that pops up, this thing right here. And there's a lot of items here that you can select from that are default. These are all templates in different ways, right? That's what these are. I want to create an empty class. This is the one. We've been creating empty forms before. We've done that before, but never an empty class. So now what I want to call this, you can rename this thing to character. So character would be the name down here. And then if you click the add button, then it'll create an empty class that looks like this. Okay. So the class, whenever we create something empty like this, we get the namespace, we get a bunch of other using statements up here, and these are just there if you need them, right? But notice that if you hover over, they're all kind of grayed out because right now we haven't done much with our class. That's something that you can look at. There's also this internal, we can change this to public if we want to, and it's perfectly fine. It's not going to break anything if we left, if we left it an internal or public, but we want our class to be public. We want it to be used by everyone else, right? So once we've done that, we're here. Notice it says internal. I like to I want to try and set up our structure. And the way to organize this is by, I use a little bit of comments to do that. So I kind of start off with, I think about where I'm going to put my, private instance members, also called fields. That's where I put them. Okay, I put them at the top. Then I put some public properties. So public properties are here. Then I make some constructors. Look, it even knows what I'm going to say. And then after that, I have methods. And there's two types of methods. Public methods, really, at the end of the day. And then maybe some private methods. I'm not sure we're going to do any private methods today. Right? But those are the areas that I kind of think about. And that's kind of the anatomy of a class that I kind of think about, right? So I kind of start off with my character. And then from there, I want to start thinking about things that I want to use. We know that we have something. I'm just going to close some of these things down right now. We have something in the program.cs already. If we look at it, we have all these, right? These are character data from our struct, right? So we want to kind of mirror our class to make it look like this, right? But we don't want to use public for everything. Public means that we're violating the encapsulation principle. The first principle of OOP is private instance members, public properties. So if we just do this, that's not really what we want to do. We're actually going to say, wow, we don't want to use OOP. We're just going to do our own thing, right? We want to try and use OOP. So I want to try and make private fields. And I want to use the way we've done this. So I'm going to say private, that's the name. Private means it's inaccessible outside of this class, this little document here, right? And then I'm going to say the string, and then the name that I want for the first field is going to be m underscore and then agility. I'm going to use the whole name this time, okay, instead of part of it. I want to do the same thing for the other one. So private string m underscore strength, private string m underscore figure, private string m underscore perception, and private string m underscore intellect. And the sixth one is private string m underscore will. Okay, those are all of our attributes that we have. And that's the first step that we want to put in. Okay. I never would make them separated by commas, ever. It's incorrect. Don't do it that way, please. Less maintainable, right? So I would never do it that way. So if you've ever seen that, or if you see it somewhere, or if someone tells you to do that, it's wrong. Okay, I'm telling you now, as your professor and as your friend, right? If we ever program together, don't do it. okay? Separate all the time. All right, so it doesn't matter if you're using code for your game, whether it's in Unity or an Unreal Engine, together is laziness. All right, we don't want that. We want separate. There's no advantage to it from a memory perspective. It's the same memory, and it's way less maintainable, than this. There's no quota on how many lines you use, by the way. Okay. So yeah, so that's the first thing. So this is that we would do first. So this is our instance members, and I want to just be respectful of our thing. There's not a lot to do today when it comes to this. We haven't. I want to build up my class. So the first thing I'm doing is this part, right? Which is this. This is where I'm at right now. Okay. The next thing is my public properties, right? So public properties, I want to start typing the word public, and then string is the return type or the type. Agility would be the name. And just like what it's done here, this is an example of a public property. It's trying to fill it all in for me. But this is an example of a public property. There's two parts to it, right? There's the external part, which is this part. This is the part that you'll see outside of this class, agility, right? And instead of agility being like this, to keep it the same, because we want to make this a drop-in replacement for our struct. Our struct right now in program uses AGL. So we're going to make it a drop-in replacement for that. So we're going to just call this AGL, okay? But in the back end, it's still going to use the backing field, which is agility. So what it's going to do is when you use AGL to assign or read data, it's actually going to use these two things. And these two things is called, this is a getter. So this is, what this is called is a getter, or also called a get accessor, okay? And this is called a setter, right? Setter, which is a set mutator. Okay, that's what they are. So set mutator, that's what they're called a lot of times, or setter. Getters and setters are the most common way of referring to these things. In other languages, getters and setters are separate methods. You don't have this structure in C++. You don't have this structure in Java. You don't have this structure in JavaScript or TypeScript or any other language. It's C# specific that we do this exactly, right? So get set, that's just a getter and setter, and it represents agility, right? So in other languages, you might say something like get AGL or set AGL, two different methods that you would use for this kind of thing. Here in C++, C#, you can just use agility or AGL, and it's going to represent either get or set, depending on what you do. So kind of a really neat thing, and that's why C# is so flexible and beautiful, right? Because they don't have to use extra methods; they're just right here, right? So these are not just kind of a way of getting and setting data; they're also methods, even though they don't have parentheses, right? They don't and you might say, well, they don't take any parameters actually. Well, this one does. So value is a special keyword. The value keyword is reserved, right? You can't use it somewhere else in your code ever. What value is, it basically says that the value that you're going to pass into agility or you're going to assign to agility, the literal is, this is what this represents. So it's a special keyword. So what's going to happen is when you do something like character.agility equals to something else, on the other side of the equals to, whatever literal you put there is represented by value. Okay, that's what it means. So that is an example of a property, a public property. And again, it'll be the same thing if I do, kind of our strength property, right? And we'll do all of them, right? So there's our vigor property. It's going to say the same thing. So vigor, it's got to be coded in the exact same way. And I have this in the PowerPoint if you actually look. So there's perception, and there's intellect, and there is, scroll down here, will. Okay. So those are all the different properties, and they're pretty long. Like when you look at them, they take up a lot of lines of code. And so some C++ programmers might, this is a criticism for this, it's a lot. It's very wordy because you have, all this stuff. But realistically, if you're going to do this in C++ or another language, you'd have two methods, like actual functions, two methods for every property that you've created, right? This structure where you have private instance members, and public property supports the idea of encapsulation, where we have an envelope, the envelope or a threshold guardian, or whatever you want to call it. I can't access agility directly, this part. I have to go through the AGL window, kind of thing, or the door. You have to go through this method in order for you to do this. And students, when they first learn about this, say like, but why? I don't understand. Why would you create this extra layer? That's what this is when you're accessing data, right? And it is a gatekeeper. It allows us to validate the data that's coming in. So if we want to do validation, we can do it right in here if we really want to. Okay? So that's something to note about public properties. Next, once we do the public properties, what we want to do is we want to use constructors. So constructor functions, there's two constructors. One of them is the empty constructor, and the empty constructor is going to be just this, right? So no parameters, right? So we'll say this is the, this is the empty or default constructor. Let's actually say default or empty. Default or empty constructor, right? The default or empty constructor exists with almost every programming language out there, not just C# specific. So the things I'm talking about today, OOP, is not just C#. It exists in other languages. OOP is a programming design pattern, and the language has to support it. Our general purpose programming language, which is C# that we've chosen, is just one. There's C++, there's Java. Those are two other general purpose programming languages, and there's many others that do something similar to this, right? So character is the empty constructor, right? Now notice if I hover over, it says non-nullable field M agility must contain a non-null value when exiting constructor. Why? Because it says consider adding the required modifier or declaring the field as nullable. So we don't want to do any of those things, right? It's very simple. All we really need to do here is we want to make references to all that stuff. So I'm going to say m_agility, and we're going to set some value. I'm going to set it up to 0. And we're going to say same thing with strength and vigor and perception and intellect and all the other ones. Okay, so those are the first things we're going to do. So those are the first things we're going to start off with. These 6 attributes that we're making, they're going to have 0 values. Now we also have 3 other attributes that we want to use, 3 other things other than these primary attributes. We have a character name, we have the career, and we have species. And for this, I'm going to go back up to properties again. So these properties here are long form properties. There's also something else that you can do, and they're called auto properties. Let me explain these things. So if I do auto properties, right? Auto properties are a special way of doing things. And so there's 2 ways of doing it. One way is typing it in, public string name, and instead of actually putting in the detail for the getter and setter, you just put in get set. So this is auto properties that allow you to do this in C# only. Okay, again, other languages don't have this. This is a C# construct, but it's good for you to know, right? So what an auto property does is it kind of assumes, like if you have no data, if all you're doing is this, it's kind of a waste. That's what auto properties will say. Actually, if you actually hover over this, and if you kind of go to this, it'll say convert to auto property because you can do that. And you can make will an auto property as well. Take a look at that, right? Let's undo that change, as an example. But you can convert all these. We're not really doing anything in any of these things. All we're doing is reading and writing. So therefore, there's nothing special going on. We don't have any special logic that's happening in any one of these functions. So therefore, doing something like an auto property would probably be okay, right? And it wouldn't break the convention because there is no backing property. It is public though, so that's the concern here. One thing that you can do is if you start with an auto property like this, you can always convert to a long form property like this. So for example, if I went to the name and I went to the little light bulb here, and if I said, removed unused property is not thing, but if I say to property with backing field, right? If I wanted to do that, if I clicked on that, all of a sudden it becomes a long form property, and I can even, this is kind of a short form from doing the same thing. We're not talking about that here, but I can even go to instead of using it this way, I can also convert this into a long form thing that looks like this. Okay, So there's many ways of kind of doing this kind of stuff, right? So things that you can also do. Okay, so let's undo those changes. I don't want to convert this to anything else with the backing field. I just want to use an auto property for name, because name, well, I mean, how much can they mess up a name? We could say, well, if you add alphanumeric characters, maybe we can have a validation for that. The other one would be species, right? So if I said species is the other thing. So there's one other way to make auto properties, and you can use the prop keyword. If I just type in prop, notice that there is here, right? So there's two ways of using this in Visual Studio. This is a quick thing in Visual Studio. If I use prop and then tab, right? Then what it does is it creates the structure for my auto property if I don't remember. And then it kind of says, okay, type is thing. So what's the type? So it's going to be a string type. If I press enter, it's going to take me to the next thing, which is the name of the property. So career will be the next thing. I press enter, and now I'm done. That's the second auto property I've made. So you can use the prop keyword for that, right? And I'm going to do the same thing with my other property, which is going to be species, right? Okay, so those are the three auto properties that I want to use, and it makes sense to use those because I'm not really doing anything special with them. I don't have to validate anything like I do with will and everything else, right? I still need to initialize them. So, and even though I've put them in here, I could still initialize them. So let's put them in. So I'm going to say name is an unnamed thing, career, unemployed. We could say like, unknown. We can actually put in known, like those things are unnamed and unknown if you really want to. And species is also unknown. In fact, you can also put unknown for all of them. Or you can just leave it as blank, because blank satisfies the requirement as well, right? So something like name, unknown. Unemployed. I know I like unemployed too. That was pretty good. But anyways, this is an example of initialization. So here what I'm doing is I'm initializing, our instance members, right? And these are instance members here because they're m underscore, and our auto properties. Notice I'm using the property name here instead. I'm initializing them with some value so they're not null. They're not uninitialized. They have to have something. That's what this empty constructor does. Let's make a second constructor, which is a parameterized constructor. This is more complex. So I'm going to say second constructor, same name. And this time I'll take in a string that's a name, right? Another string that's a career, or let's say a species next. String, species. I did that, and I don't know if I did in that order. Let's see if I did. I want to keep the same order that I kind of specified here. So this is these. I talked about properties. I talked about auto properties. That's what those are. And then, oh yeah, we're going to come back to this in a second. But I want to, what did I do here? I said string, career, species. Yeah, I was right. String, career, species. Just want to make sure it's in the same as the PowerPoint. And then I want to have string, agility, string, strength, string, vigor, string, string vigor, string perception, string will, and then at the end of the day, it's going to look like this. So, so what is this? This is a parameterized constructor, right? That's what this is, and it gives the user options. They can do either this or this when they're constructing the object, right? Either one is okay. That's what's happening here. Okay, so that's what the parameterized constructor might look like. We can have a second parameterized constructor. What if a user says, I want to put in values here, like actual integer and stuff like this? Instead of them converting the values outside of this class, what if the class itself converted the values for you? So you can have that too. So I can have a second, we can have a overloaded or overridden, overloaded parameterized constructor. And what it would be is public character, as an example. And here we'll take string name, string career, string species. And instead of having strings, we'll just have integers. So I'll say integer agility, integer strength, integer all that. And what it'll give you is it will convert your agility by using the toString method. Now, this is interesting. ToString exists almost in for everything you want. I can convert an integer to a string. This is an integer. The toString method exists on the integer primitive, right? So I can, use this toString method to do that. ToString converts this to a string. That's what it does, right? So the great thing about these two things is whether I enter an integer or a string, as long as they're all integers or all strings, I can do either one, and I can construct my character either way. If I want to put integers or strings, it doesn't matter. At the end, the backing fields are going to be satisfied, the instance members, because we're going to convert everything back to a string here, whether you add a string in or not. Okay. One thing to note is you cannot go back and forth. I can't do like agility is an integer and then strength is a string. That's not something we've covered here, right? The other one is, what if I just wanted to specify name, career, and species like it's suggested and not put any of the other ones in? We can do that too. There's many ways we can make this more flexible. So we have constructors, 3 different kinds of constructors. The other thing that we talked about, what about those funky other secondary attributes like awareness, toughness, and resolve? We don't really specify them here, and I don't need to save them because they're computed values. So one thing we can also do is, instead of having these properties that look like this, I can have computed properties. And what computed properties are is they're actually computed at runtime. So if you are to try and they actually look like properties, like as if you have awareness, toughness, and resolve. That's what they look like. But actually, it really depends on, those properties really depend on the other ability scores, right? So what you can do is we can also have those. We can have computed properties. Okay. So we can have a public, and we want to compute them. So I want to have a value like int, let's say, and I want to make sure that I did this right because I don't want to mess you up. Did I make them int? I did. So int awareness as an example, and just like we've done before, right? Then we want to say something like this. I want to return or get, right? And I'm only going to have a getter that returns the 2 things. So I'm going to say int.parse, and I want to parse my agility, right? So that's awareness. Plus, I want to add in int.parse. I want to add in perception like we've done before. And that is going to be my awareness. Awareness is basically doing this. And we've done this before. We've seen this before, this pattern. Now, here's something new. There's only a getter. All right. So getter is only there. When we only have a getter for something that looks like this, then what we actually have is a read-only property. We can't write to it. If I take away one of these setters, by the way, we've created a read-only property because I can only get to it. I can't set to it. I can also have properties that are write-only, but very rare. It's weird that I can only write to something, but I can't read from something. Weird, right? Usually get a read-only property is something we have more often, right? All right, so there's awareness. We can do the same thing for toughness and resolve. So I can say public int toughness, right? And then that could be get, and then we'll do the same thing, return int.parse. Toughness is a combination of strength and vigor in this game that we've been making. Oops. Right? And finally, oh, vigor, I'll be okay. Strength and strength. That could be something too. But let's do this, public int, and then we'll say resolve, right? So resolve will be the same thing. When we say get and then return int.parse, and we'll say int plus int.parse will, and that would be your resolve. So we have 3 computer properties, awareness, toughness, and resolve. And what they do is there's nothing that they actually store. They don't store anything. Instead of storing data, all they do is they use existing data to come up with it. In fact, in many ways, these are like other types of methods, right? They're just methods. And if I want to get my awareness, it just computes these 2 things. If I want to get my toughness, it computes those 2 things. So this is something of a computed property as well. Questions so far that I've gone through this stuff? So just to understand how things are working here, just being aware of the time. One last thing is there are public properties, and I can make public methods here if I want to. We're not going to have any private methods, so we'll leave that blank for now. But public methods, there's a bunch that are built in, because one thing to note is even though I'm not inheriting character from anything, character, I want you to know, is still inheriting from something called object. Object is the superclass of all superclasses here, right? So it's actually inheriting from object, the object superclass. That is by default what character is inheriting from, okay? Because object exists at the very top of the hierarchy of for C#, and actually in many languages, object is the way we go, right? So because of that, because character inherits from object implicitly, not explicitly, I'm not telling it to inherit, it just does, right? We have a lot of inherited members. So one thing to note is I could notice the default constructor, it allows me to do different things here that if I just click on the class, it tells me to do this thing, right? I can make it internal if I want to. I can do a bunch of stuff. But one thing that we can also use is we can use a built-in function. There's a built-in function for all classes, and there's 3 of them. 4 of them actually, but anyways, let's go back. So one of them is the toString method. So I can do public override, right? And notice if I do that public override, I have 3 options. I can use equals, I can use get hash code, and I can use toString. So equals is interesting because that means if I want to compare one character to another, I can actually write the code right here, equals. How do I compare one thing to another? Is this one is equal to this one? And what is my custom code to do? Do I compare every value? Is that what equals means? Right? We have to we can kind of decide what this means. But anyway, there's a lot of other things we can do here. We can override all kinds of things. But for now, let's just override the toString method. So the toString method is interesting because it's built in to every class, just like we had it up here. Look, there's toString, right? So I want to say, like, how do I convert my character, my data into a string? So what we want to do is this. We want to say that I want to convert it. And by the way, on page, like we mentioned, David mentioned this earlier. This I just didn't put it on one line. This should be on one line. So if I was to take this little code here from the PowerPoint and put it right here, it's going to error out. Show you what it says, right? It's going to say, "Nerd, sorry," right? Because it's this raw, it's a raw string. That's what it is. I don't have to make it a raw string, but remember there's ways of creating this so that I can use, I can make it a string. If I did it just a regular string, and if I use, as an example, a $sign in front of it, like each string, right? Does it really do anything? So that would be something I can do. But what we've done is we've made it a raw string. Let's go back to that. And if I make it a raw string or a string that I can do, it have to be all on one line. That's what it has to be, right? So all of this has to be on one line. Let me just do that again. There we go. And same thing with the curly, the end. So this is kind of on one line. It's just broken up because I'm using my thing. It's got to look like this. So let me explain how this works. So basically what I'm saying is take name and inject it in here. That's what's happening here. I'm injecting name in here, career, species, and then I have extra information here where I'm actually outputting the entire value of all the properties here. And this is a very common way of doing the toString method, okay? Tostring methods we use because we can troubleshoot. We can actually look at what the data that everything is holding. Instead of me going through each individual property and saying print this, print this, print this, I can use the toString method to do it for me. Okay, so that's something that we can do as well. All right. So this, my friends, is the character class, and this would be our first version. If we were going to continue this semester, and if I had more time with you, we could embellish this class and make it a more detailed class with lots of stuff in here. But for now, we don't have that time, so we're just making it like this. And then I want to put this up on GitHub. So back to developer PowerShell, I'm just going to say git add dot, git commit -m. I'm going to say added character class. Git push. So the character class that we've added, well, I want to do something with it. And if I go back up to what you need to do now, we've talked about arrays of lists. We've made our character class. I showed you how to do that here on these pages, but there's some stuff for you to do. So here's what I want you to do now for the remainder of the class. We have some time. I want you to replace all instances of my character data with my new character class. Now, there's a couple of challenges here. Okay, this is the first thing I want you to do, right? So if I have my character class now, here's my character class, I can close it down. If I look at my program .cs file, if I go down and if I look at character data, this is the character data struct. If I search for it right here in my document, let's take a look at just the current document I'm searching for. I can see where it's being used in load character. It's being used in all through here, right? This is character. Let me see if I can make it so that it is case sensitive. Match case. I can use it in load character binary. I'm using it also in save character JSON, and I'm using it in load character JSON. These are all the places that I'm using this thing in, right? Right now. So there's a few places, and I want to replace it with our new class, character. It has all of these. And to show you this, imagine if I was going to instantiate an object of type character. So how would this look? So I would say something like this, character, and let's suppose I want to make a character like Conan again. Character Conan is equal to a new character. So I could do this, the empty constructor. I can do that. And that Conan would be the empty constructor. Let's print that out. So if I do a debug.writeLine, I can do that right when I run my code. And if I want to debug Conan, right, because Conan has a toString method that I defined, I can just do this. If Conan did not have the toString method, you could not do this. All right, so let's try this out. If I was to run this code, this is going to happen in my program.cs when main launches. It's going to output this, and it'll output it to the output log. Let's try this out. So if I run my code and try this out, then here it is. And if I look at my output log here, right, as an example, then somewhere, here's my debug log, somewhere I want to output what Conan has. I instantiated an object of type Conan, I ran my application, as an example, this is in the main function. So, where does this belong? Well, it belongs here. So how come I can't see it? So if I go to debug, that's what I'm looking at, right? I can also look at Windows Forms. These are all the Windows Forms things that are happening. You can see all those fields. And I can go, I go back to debug. So debug is where this would come up. So if we're going to have, the Conan form come up, it'd be here. All right. So this is something that we would look at. And notice that there isn't anything here. So what happened? How come it's not showing up? Right. We can try other things too. For example, I can do another debug.writeLine, debug.writeLine. And this is when the things are setting up. That's what this main does. And we can say like, hello. Let's see if it goes there. Hello, right? Because we're kind of setting this up for the first time. Save. And if I was to redo my app, let's see, do I actually get to see hello, right? And you can see that it says loaded, but that's all that debug does. Now I can also look at debug, and I can go to my Windows as an example, and the output window is what I want to look at. So definitely it's coming here. That's where it's coming, right? Now, one thing also that's happening is we're doing this after the application run, and maybe when it will never get here because it's doing something, it's live in the application run. It's going to the splash form. So what about if we did this inside the splash form or before that, before the application run? Let's do that before that. Before we run the application, we're going to do that. Excuse me. Let's try this again, right? Because the application is live, right? That's why it's not doing it. There we go, right? So if the application ran, and here we have unknown, 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 agility. I'm going to bring this window bigger so you can see it. Agility, strength, vigor, all that's 0 because that's how we set it up. And also notice that there is like no space between agility equals and 0. I don't like that. let's fix up our character. So under our character, I'm just going to stop this. And inside of my toString method, by the way, on the left, you can search the document outline and you can just jump right to this toString method here. It's another way of searching through stuff. And here, notice that there is no space, right, between this. It has this space, but this isn't right. It needs to look like this, right? That's what it kind of needs to look like. So that's incorrect, actually. Otherwise, what's going to happen is, yeah, I'll accept that change. Otherwise, what's going to happen is you're going to have, the wrong thing. So let's try that again. And I'm going to go back to my program. I don't need the hello anymore. We know that this works now. And I just want to run Conan and see what happens, right? So let's try this out. So I press play, and there it is. So unknown, agility 0, blah, 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 and that's it. Okay, so you can see that that's how it works. So now what about if I wanted to add in, this is the default constructor. That's what this is, right? So is there a way I can do it with a more complicated constructor? Let's try that. So I'll say the name is Conan, right? Then you can see if I press space, the career is what's is next, and then species, barbarian, right? And species is human. Now I can put either a string or a number. I'm going to put numbers in this case. So I'm going to say his agility is pretty good, right? Now notice that I'm using the first constructor. It's jumped to that one. I'm not using the string anymore. I can't use strings and interpose both. I can't just do, something like this and say something like, 50. I can't do that. It just doesn't compute because it doesn't know what that means. I can't go back and forth between strings and numbers, but I can do 50. That still computes. Let's say I got 50 strength. I'm making this up, as an example, and my vigor is also pretty big. Conan's a beast, right? He's an advanced character. He's not a starting template, right? And let's say I've got 30 perception and 25 intellect. And you know what? He's always had a really big willpower. So he's got a really big will anyway. And that's Conan, right? That's the guy, right? So now I want to print him out. Okay, let's see what happens. So if I press play, and then what happens is, there he is. Conan, barbarian, human, agility, this, that, that. So this is the way of, that's what toString does. So we know we can construct a character, and we can construct a character in different ways, 3 different ways, actually. I can use things like this, where I have integers, or I can use strings, or I can use nothing. One other thing that we can do is if we want to modify Conan. So once I made Conan, let's say, for example, I made a mistake and I said my strength is only 10 for some reason, right? Well, that doesn't make any sense. Let's say I want to change that. I can always say Conan.strength, Conan.strength. Notice that comes up. The dot accessor shows me all the things that I can do with Conan, right? I can do species, I can do name, I can do career, and I can do awareness, toughness, and resolve. I can do all those things, but I can actually modify strength too. So here's strength, right? And if I type in strength, right, and I can say equals to, now there's only one thing I can do. Strength only takes a string. It does not allow me to give it an integer. So I can't do something like 50. I can't do that, right? Because 50 doesn't compute. Strength, if I hover over like this, is a string. Okay, that's what it does. So I have to kind of put in strength 50, okay? And then if I was to do something like Conan, I want to not just debug right line Conan, let's say I want to do that, but I also want to debug right line his abilities, his things. So I can say debug.writeLine, and oops, and what I want to put out is something like my awareness, which is going to be equal to plus Conan.awareness, or I can do it this way, and then I can go plus toughness, put that out there, where I can say Conan plus toughness, and then I can go plus resolve, oops, which is plus Conan dot resolve, right? I can do that, and awareness, toughness, and resolve are going to compute. Those are computed values that I can print out as well. Let's try that out. So save, and if I press play, then I should see all those kind of things happening. So here it is. Conan, barbarian, human, agility, right? Oh, I made a mistake there, but that's okay. Now look, his strength is back to 50, even though he started off at 10. I modified his strength here. This is a way of modification. I made it 50, and now you can see his awareness is 65, his toughness is 95. That's only because I didn't do this, right? And his resolve is 60. So that is something that you can do. Notice I'm using computed properties here, right? They look like they are part of Conan's abilities, but they're not. They're just computed at runtime, right? That's how they work. Okay. So so that is an example of how to use the character itself. This is ways of doing this. Remember, we can also do things like this. Instead of making a character, I can just call it character data. And this is what I've asked you to do. I can say character, that's my character. I can say this is character data, right? I can kind of do one of these. And then later on, what I can do is I can instantiate. I can say is equal to a new character. I can do that, right? And so what this does is initialize this stuff with nothing. And then later on, what I can do is go through and change this to something else. And this is what I want you to do for you to do, okay? So that means in here, where I've asked you to do your thing, I want you to comment out character data, the struct, and put new character in here instead. And then the one funky thing is that the character data struct has a character name, but you need to change yours to just name. So any place that gives you an error, it says character name doesn't compute, name in there is what you need to put. Okay, that's what needs to happen there. Okay. So that is part one of your to do. The other thing that I want you guys to do is I want you to make one file for each one of these things. And the reason why this is bad is because right now what we have is we have a lot of different things here. We have form type and toast type and character data. I don't want you to delete, by the way, struct. The struct, I want you to keep it. This is our first kick of the can to try and make kind of a data container, which is a struct, right? So I want you to keep it. I want you to put these three things in different files. That's what I want you to do, right? And there's also one more of these that's contained in selection form, if I'm not wrong. If I go to selection form, you can see that I also have career as an enum here too. Notice that they're all over the place too. Like one is in selection form, another one is here, another one is there. It's very unorganized. And we don't want that. We'd rather have each of the constructs, whether it's a struct, an enum, or a class, in their own files, right? So how do we do that? So remember, it's the same thing. I'm going to right click here and right click and add new item. Now there isn't an enum, all right? There's no struct or class here that we have to do. And, well, sorry, there's no struct. There is a class, but there's no enum or struct. So my recommendation is we start with class, right? And I'm going to do one for you. And I've showed you this already. I'm going to change this to whatever we say here in the book. So I'm going to say toast type. Let's do the toast type class. So I'm going to grab this one, right? And I want you to change this to toast type, right? Now, if I do toast type and it's a class, it's going to give me that same structure. It looks like this, right? But I don't want it to look like this. This is not a class. It's an enum. So the way to do this is to go and grab the toast type enum, cut it out, right? So I'm going to go to program.cs, go to the toast type enum, cut it out. So go here, cut it. So Control X. You can also right click and cut if you really want to. That's also something if you don't know Control X. Control X to cut, then go back to your new toast type.cs file and replace this part with that, which is this. And now toast type lives in its own file, save. As an example, and we can say that view, terminal, and I want to say that git commit minus m, and we'll say moved toast type enum to its own file, okay, and then hit push. So whenever we move things like this, I want you to test. All these things require a test. So let's see if toast type still works. So if I press play, as an example, is it crap out somehow? If I load something, let's say, for example, I load, rando the commando again, right? Random the commando, there we go. I load it up, look, there's my toast, it worked. right? So we know that it worked, which means when I moved it over, it didn't break anything, right? And that's one thing I want you guys to do. So notice that I have one of them, toasttype.cs, and what I want you to do is go through and do all of them. And I've given you an example of what it would look like at the end. Career.cs has got to be its own thing. Your struct character data.cs is going to be its own thing. Form type.cs is going to be its own thing. And of course, we just did toast type. Okay. So that is part 2. And that's it, my friends. Right? I don't want you to do too much this week. It's going to be an easy in-class exercise, and for it should be for one reason. I want you to have a chance to practice and catch up on what you know. So if you are stuck on something like that we did in the previous in-class exercises, go back and do those things and try and figure them out. If you can't figure something out, okay, we have between now and between Friday for you to book time. We have still some time for you to book. I still have room in my calendar next week for you to book time with me if you have a problem understanding something. So if you don't know about something, if something's not working for you, if your previous in-class exercise failed, or you have a problem with Git, GitHub, anything like that, please come out and see what you can do. Sorry, I haven't spoken in a while. I just heard that my Teams server got deleted by Brandon. Server. You mean you have your own Discord server? That's too bad. I wonder why that happened. That's too bad. Yeah, I wonder if you guys lost anything. But anyways, so yeah, so that's what I recommend. So please, that's terrible. Hopefully you guys have everything on GitHub, which is what you should have it, right? So please, what I'd ask you to do is book some time with me if you don't understand something. There's a little bit of time left, okay, between now and Friday. And if you're concerned about something, like you're worried about where your marks are, I've already given you most of your marks. There's only a couple of in-class exercises left. I'm going to go through those as well this weekend. And this way you'll have all your marks as you enter the exam. Please make sure you kind of meet with me, and if you have a concern, like if you're very close, and there's some of you, maybe not people that are here in this meeting right now, but some of you in the course that might be watching this video that are very close to not passing or very close to not doing great, as an example, please connect with me, right? Because if you're really concerned, we have to talk about how to be successful on your test. Your test is worth 20% of your grade. It's an opportunity for you to do really well and then pass for this semester. If you don't pass this semester or something bad happens and you get very low marks, it's going to affect how you progress in our game dev program, right? You won't be able to connect to stuff that's going on next semester. You won't be able to take like the part 2 of this course, Game Programming 2, if something goes wrong. So please connect with me if you're concerned. Okay, I want to make sure that you're shored up if you have a problem with it. And the way you connect with me is not on Discord. Some people are trying to reach out with me on Discord. That's not how you do it. Okay, you connect with me through Blackboard. Like I've said this many times with you guys, if you have a problem, Blackboard is your friend. And the way to find this is, if you go, let's go to Blackboard. Again, I want to say this one more time. Some people have done this, some people haven't for whatever reason. Maybe they don't know about it, or they didn't watch the video, or whatever. That's okay. But I'm going to show you one more time. Hopefully you're watching this video when we're going through this so you understand what to do. But let's go to your Blackboard. So if I go to Blackboard, and if you scroll down, there's office hours. Okay, so please book time with me. What it will do is it'll look through my schedule, and if there's time slots that are available, it'll book. I'm booking up quick already for next week. Right, so please make sure you click on this if you need time with me to discuss something. If you're concerned, you don't understand something, you want me to clarify, this is the time. This is the best time to do it. So that way you know what's happening. So before we get into our exam, because we're going to do Windows forms 100%, we're probably going to use methods 100%. We may do some kind of input-output, most likely, right? So those are all the things that we've done so far, things that we've covered up to week 13. It's all fair game. Will I put classes on your final? Maybe just because we just did our character class, it'll be there. But will I make you do anything else with it? Probably not. I'm not sure that I will. Do you know what I'm saying? Because we just covered it. So it's like, it's kind of fresh in your mind. You haven't a lot of time to play with it, and it's really a topic of next semester. So I probably won't book classes, but structs are fair game, right? and you know, and so are enums, and so are all the other constructs that we talked about before. All right, questions around today? Any questions? And the things that you need to do for your in-class exercise 12. I think it's pretty straightforward, and I think you can be very successful. It'll boost your mark a bit if you just be able to, you know, that's why I made it a little easier as well to follow through. So that way it's kind of, you know, you have some tougher in-class exercise, you had some, you know, easier ones, and this way by the end, you've got a pretty good mix of marks. I think a lot of you guys have been doing really great in the second half anyway, so I think it's really bolstered up your mark, and I think this would also help as well. All right, so any questions before we go for the day? And if you don't want to do this on when we're recording, I'll stop recording now, and then you can ask questions. I'll stick around. We still have some time. So I'll stop recording.